Okay, so the question is, the molar mass of a compound is 145.9 grams per mole. A sample of the compound contains 0.317 grams of carbon, 0.043 grams of hydrogen, and 0.280 grams of sulfur. Determine the molecular formula of the compound. So, that question is asking us to find the molecular formula, but we don't know what that is yet. So, a molecular formula is a formula giving the number of atoms of each of the elements present in one molecule of a specific compound. And in order for you to get the molecular formula, you first have to get the empirical formula. And then empirical formula is a chemical formula showing the simplest ratio of elements in a compound rather than the total number of atoms in the molecule. So the first step in this problem would be to convert each gram of the given element to moles. A mole is just a scientific unit for measuring large quantities of very small entities such as atoms or molecules. The unit conversion to find the mole would be molar mass equals grams per mole. The molar mass of each element is given to us in the problem. So for carbon, it will be 0.317 grams. For hydrogen, it's 0.043 grams. And for sulfur, it's 0.280 grams. And now, for you to set up the equations, you just set that molar mass given to us, multiply that by 1 mole over however much the element weighs, which would be the atomic mass. So in the first part of the problem for carbon weighs 12.01 grams, and you find that number, the atomic mass, by looking at your periodic table. You find the element that you want, and the atomic mass is the number below that element. So for example, if you look at H on the periodic table, the atomic mass would be 1.008. So that's how you get the molar mass of each of the elements, and you set it as 1 mole over the grams because you have to find the moles, so the grams will cancel each other out, and you'll just be left with the moles. So you repeat the step for carbon, hydrogen, and sulfur, and once you do that, you find the results as 0.026394 for carbon, 0.042658 for hydrogen, and 0.008730 for sulfur. And now once you do that, you find the smallest number. In this case it's sulfur. So you divide all three of those numbers by that small number. So you divide carbon by 0.008730 and you get 3.023 carbon, or just 3 carbon. You divide hydrogen by 0.008730 and you get 4.886 hydrogen, or 5 hydrogen. And you just divide sulfur by the number 0.008730, which you will just be left with 1 sulfur. So once you do this, you put it into its empirical formula. So the empirical formula will be C3H5S. You get C3 because there's 3 carbon, because as you guys can see, it's equal to 3.023 carbon. So that rounds to just 3, and that's how you find the subscripts for each element. So it'll just be C3H5 because the 4.88 rounds up to 5, and since there's only one S, you write S. Now you got the empirical formula set. Now you have to find the molar mass of C3H5S. And in order for you to do that, you multiply 3 by the molar mass, or the atomic mass of carbon. The atomic mass of carbon is 12.01, and you just look at the periodic table and you get that information from there. Um, So it's 3 times 12.01, 5 times 1.008, and 32.07. So you add all that up and you get 73.1368. Now once you get the molar mass with the empirical formula, you get the molar mass of the compound provided to us in the question, which was 145.9. So you get 145.9 and you divide that by 73.1368. Once you do that, you will get 2. Now you apply this 2 to the empirical formula. You multiply 2 to each of the subscripts. So for C3, for carbon 3, you just get the 2 and multiply that by 3. Since there's 3 carbon, you do 3 times 2, which is 6. So you get C6, H10, because 2 times 5 is 10, and S2. Since there's only one S, you do 1 times 2, which is 2. So your molecular formula in this problem would be C6H10S2. So the question is, which of the following elements would exist generically as X2 if in its pure form? So a pure element is a substance whose atoms all have the same atomic number or number of protons. A pure element can be broken down to an atomic and a diatonic. As you guys can see, an atomic element consists of only one of that element. So in this example, I'm giving you guys Ar, and there's only one argon by itself. So it's Ar as one, and then another Ar, and then another Ar. So they're not combined, it's just by itself. It's just one atomic element. And a diatomic molecule consists of 2 atoms of the same element, such as H2 or N2 and all that. The prefix di is a Greek origin meaning 2. So, for example, nitrogen gas has 2 nitrogens combined together making a diatonic. As you can see in the example provided, there's 2 nitrogen atoms in one, so you write it as N2. And the only diatonic elements are hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. And so in the question that we're asked, we are given the options silicon, phosphorus, neon, and iodine. And as you guys can see, the only diatonic element in here is iodine, because silicon, phosphorus, and neon aren't. And since it's asking us X2 in this pure form, we just went over that diatomic elements are written as X2 in this pure form because there's two atoms of the same element.